So October is our at Data Community DC. Yay! Come on! So we have 3 really cool talks lined up. Of course, the first one is tonight with Garett and Nate from the RStudio team. Well, actually, everyone who's talking is from the RStudio team. So on Tuesday, next Tuesday, it's going to be Joe Rickert who's going to talk about the past and future of R, and that's going to be a data science DC event. And then on the 19th, so 2 weeks from today, the one and only Hadley Wickham. Yay! And he's going to be talking about more advanced R stuff. So I think we're going back and forth, but something along kind of expressing yourself in tidyverse, and something. I asked him to do something that's more advanced because I think between Garett and Nate and Joe, they're going to cover some more like basics, and then I asked him to do something that's a little bit more advanced. So really looking forward to that. Probably expect a full room for that one. So that's on the 19th. Special welcome to the R ladies. Folk, R ladies, are you here tonight? Yay! Welcome. So is Kelly here? Oh, hi. Sorry. Hey, thanks for coming. So thanks for moving your. So if you don't know, for all of you ladies, go talk to Kelly. She is organizing Our Ladies DC, and Our Ladies is sort of a global community of R for ladies and to promote diversity. As we have Women Data Science DC here, so maybe we should talk about bringing everything together in one single umbrella. Probably makes sense, but we'll leave that. Anyway, welcome. Please, I'm sure I'll see you guys around. All right, so. You've seen this before, well, maybe some of you have. Raise your hand if you are not familiar with Data Community DC. Okay, so, well, for those of you that aren't, welcome. We are Data Community DC. We are a community that promotes the work for data science and analytics professionals in the DC area. We started in 2012 with 2 programs, this program at Data Science DC, and over the years we've grown. I just pulled the data last night from meetup.com, and our reach right now is over 20,000 people in this metro DC area. So thanks for coming. We have different programs, Data Science DC, Data Viz, that's programming, data education, data night owls, women data scientists, data wranglers, Nova Data Science, and Full Stack Data Science. And they each have their own unique personality, cover a different spectrum of the data science world. Some of them are geographically located, so Nova meets up in, I think, in Herndon, in Northern Virginia, whereas we do most of our stuff here in the DC metro area. So find us, our website, newsletter, etc. And question, who attended DataCon on Tuesday? Oh, cool, so thanks. So we hosted, Data Community DC had our first ever kind of data science conference, DataCon on Tuesday. I wasn't able to make it, but I heard it was a great success. So for those that went, thank you. Thanks for supporting us. We are really excited. All right, so folks, those yummy empanadas you had up there, which by the way, there's food left over. So if you're hungry, feel free to grab some more. I just wanted to make sure that there was food for everybody. So thank you very much to RStudio for sponsoring food and beverages for tonight. So Garett and company and RStudio team, thank you. Our budget is running low, hint, hint. Stats Programming DC needs new sponsors. We have our current set of sponsors up there. AOL, O'Reilly, Booz Allen have been long-term Data Community DC sponsors for a long time. Microsoft has been a sponsor for Stats Programming DC for a long time. Of course, our kind of host and food purveyor for tonight, GW, who lets us use their facilities, and we've had a long-term relationship with them. So thanks to our sponsors. I am asking for sponsors. If you want to have your logo up there and reach our entire audience, please come talk to me. We cannot do this without sponsorship money. This is a volunteer-run organization, and pretty much 80–90% of our expenses is on food and beverage for the events, and plus operating expenses for the stuff that we do. All right, I'll skip that. This meetup is about you guys. The more you get involved, the better the meetup is, and the better the meetup is, the more people get involved, etc., etc. So on the left-hand side, I just have a laundry list of potential topics. On the right-hand side, upcoming events. Well, we know what's coming in October, the next 2 weeks. We don't have anything listed yet for November. I was last meetup I said we might do lightning talks. I think we probably still. So if you want to do a short 10-minute talk, I'm looking for 6 to 7 volunteers to do an evening of lightning talks about R, Python, anything that's statistical programming related. So whatever. I mean, we're pretty open, but as long as it's fun for you and something interesting, please come talk to me. These are fun events. If you've never done public speaking, it's a really great way to get started. It's the talks that are designed to be just short and fast, and really just if you talk about something that you're passionate about, that you care deeply about, it'll be easy and a lot of fun. So come talk to me. I have a list of people that told me a while back that they were interested. I lost it. I'm sorry. So please remind me. Okay. All right, let's see. Yeah, okay. So now it's your turn. So one of the highlights of the evening is this is your chance to stand up, and if you're hiring, if you're looking, if you're running another event, if you just want to make a general announcement, the floor is yours. Just keep it simple, keep it short, please. Yeah.
I'm a Fed. We're hiring a couple of roles on my team. Lots of NLP stuff. Come give me your email, and I'll email you when the announcement goes out.
Okay, so at the end of the event, just come and stand down here so that people can come and find you. Same for anyone else who's hiring, so just stand over here and let people come and find you. Anybody else?
Hi, I'm Rafi Love. I work for Deloitte. I lead the Federal Civilian Mission Analytics. I have currently 2 open positions for data scientists with clearance, but in the next 3 months, we need about 6, 7 more. Clearance not important, so I would like to start the process now if you're interested.
Hey, I'm Kelly. I organize Our Ladies DC, like Mark said. Thank you, Mark. I just wanted to say that we have a couple events this month. On Saturday, we have a Rise and Shiny event where we are having coffee and eating muffins and building shiny apps. And then Hannah, my co-organizer right there on the corner, is doing a series of our beginners workshops this month. So check us out on meetup.com.
I work for the College Board, the data science team. We are an organization that develops and administers educational programs geared to get kids into college. We are hiring data scientists in either this area or New York. If you have any questions, you can look it up in our job portal or come on.
Hi, I'm Jay Hall from Garett University. I want to let you know we just started a data science graduate certificate.
Anybody else?
Just suggesting if people could tweet probably in
Oh yeah, if you want to tweet, our hashtag is DataDC. It's Data Community DC's hashtag, so feel free to tweet, post pictures, harass the speakers, whatever.
and probably the hiring announcements and any other announcement. It would be nice to have all focused in one place.
We could do that, or also if you want to, you can also on the message board or the messages for the event tonight, you can put it there too. So feel free to use that. And then through Data Community, we also have a more formal kind of job ads program. Get in touch with Mandy or Sean Gonzalez if you want to put an ad, and we can get the ad to the right folks at the right time. Anybody else? Okie dokie. Okay, so what happens after the meetup?
Data drinks.
Yes, data drinks. What happens during data drinks? What? Other than drinking? Other than that? I've said it before. Someone in here has to know the magic word. I've said the magic word. Come on. The magic happens. The data drinks is where the magic happens, where you get to talk to people and get to know them, and that's where the community. That's where this community has grown from. Is from all the events we've had and all the data drinks we've had and the close friendships we've developed over the years, and again, it's been a lot of work, and it's been great work, and it's been a lot of fun, and I'm really pleased with what we've done over the last few years. So we're going to Tonic, which is right down the street on 22nd 21st and G. Right, it's just like, go out of the building, make a left, go block, and it's over at the corner. And I think we have an alcove reserved from the 3rd floor. For those of you that have been there before, you know where we go. If you haven't been to Data Drinks and you want to go, just hang around after the talk, and I'm sure people will start flocking over. So hope you can join us. That's us. Abhijit couldn't make it tonight. Julia and myself. Our contact information. Please get in touch with us about lightning talks. We really want to do a lightning talks event before the end of the year. And without further ado, I want to turn it over to our speakers for tonight. So please give a round of applause and welcome to Garett and Nate from RStudio.
All right, can everyone hear me okay? All right, so I'm from RStudio, and so is my colleague Nathan. And by the end of this talk, we're going to demo some cool new products or free tools and other types of tools that we're making to help you do data science with R. But before we get there, I wanted to share some thoughts about why we're using R in the first place. Because I have a perspective on R that I think is fairly unique. You see, I've written books on R, I've written the Lubricate R package, but I actually spend most of my time just teaching people how to use R, and that's my true background as a teacher and a psychologist. And so when I approach a computer language like R, I approach it from the perspective of the human who's going to be using it. And I think when you think about R, that's the way you should think about R. And I don't just think about R this way, I also think about data science this way, and this is what I mean. To me, the atomic task of data science, the basic thing you're trying to do, is comprehend patterns that are already there in your data. By the time you collect your data, you have all of the evidence that you'll ever get, well, unless you collect more data. Your job is just to make it comprehensible to yourself. You're the weak link here. You don't know what's in there, but it's already in there. So for example, this is a very small data set. There's a relationship between the X and Y variables, but you probably can't perceive it. You may not even notice that there is a relationship here, but there's a real pattern. And the technique of data science is just to transform this data into more human-friendly formats. Always, often, almost always using a computer. That could be modeling your data into a simple equation that you can understand easily, or using machine learning to deliver some insights that you can then consume, or simply making a graph. And so if we plot this data, you certainly see the pattern between the two variables now. They form a circle. And R is a tool that lets you do this. It helps you find the things that are already in your data and make discoveries and so on. Now, as an educator, I spend a lot of time thinking about how we think and learning about how we learn. And what I've learned is that your brain is a lot like a bottle, in that it has a fairly large storage capacity. And once you get information in there, you can do all sorts of great things with it. But to get information into your brain, you have to pass it through a bottleneck. We could today call that bottleneck the attention span, but I mean, that kind of simplifies things. But this metaphor is really useful because there's a mental bottleneck. You can only think of, and this is what I showed you, can only think of 4 to 7 novel pieces of information at the same time at any one moment. This phenomenon creates what I call mental bandwidth. Bandwidth that you have to manage whenever you use your brain to do a task, like look for things inside of data sets. And if you've ever used the internet, you know what bandwidth is and you know why it's important. If you have a lot of bandwidth, that means you can download a lot of data from the internet quickly, then when you visit websites, they look like this. They're rich, they're dynamic, they have a lot of details, and it's a pleasure to see them. Unless your face is on the website, that I found to be less pleasurable. But if you don't have much bandwidth, then your web browser might show you the same website like this. Your bandwidth is slow, you can't download a lot of data fast, so your web browser compromises by showing you what it can get as it can get it. And it's the same website, but it's not flashy, it's not fancy. And if you were forced to look at these websites like this, you might miss an important piece of information. Now, this metaphor is important because your brain is like a web browser. But instead of downloading the internet, it's downloading the world. And it's doing more than that too. It's also daydreaming and remembering things and problem solving. And all of these tasks, unfortunately, consume your mental bandwidth, leaving less and less left over for actually noticing things and perceiving the world about you. We can demonstrate this mental bottleneck fairly easily. Here's one way to do it. I challenge you to read what's on the slide and pay attention to what I'm saying at the same time, because it's difficult to do. You see, you only have one neural pathway in your brain for deciphering words, verbal information. And whether you're reading those words or hearing those words, you still need to decipher the meaning and the concept of the words before you understand what's going on. Now, if you're listening to what I'm saying, you can probably understand what I'm saying, but you're not having much success reading the words that are right here under your eyes. If, on the other hand, you're reading the slide and not listening to what I'm saying, well, then shame on you, but you probably learned a little about community.rstudio.com, and you have no idea what I said for the past 30 seconds. So that's one specific type of mental bottleneck that we have to deal with as humans. It has a lot to say about how to make good slides. Don't fill your slides with text and try to compute it. But we can generalize this idea of a bottleneck to everyday experience. And I was very brave and I brought the video in my slides. Let's see if it works. This is a recreation of a famous experiment. I'll sort of talk you through it as we go. But this guy here's an experimenter. He approaches a random person on the street and asks them for directions. They start to give some directions, and then some Confederates come through with a door. And he switches with another guy in the middle of the process. More than half the time, the subjects don't realize the person they're talking to changed. And that's because the task of providing directions has consumed all their mental bandwidth, leaving very little attention left over to monitor the environment and spot important things. You could recreate this experiment in a variety of conditions, and you could push it pretty far. For example, this guy is, light complexion, brown haired guy. They're going to switch him out with someone who's, darker complexion. If you heard the audio, his voice is completely different too, but the guy never noticed it. He's too focused on the direction. And you can do similar experiences, like people won't notice gorillas walking through basketball courts and other stuff. As long as they're distracted by something, they don't notice something. Here, there's a bald guy. And one last iteration of this experiment. This time they're going to take this man, replace him with a small Asian woman. And this lady's not going to notice the difference. So what should you take away from What you should realize here is we don't perceive as much of the world as we think we do. Our brain is like a web browser, and sometimes it has to work with a very small amount of bandwidth. But unlike a web browser, your brain fills in the extra details, so you never notice, which actually makes this quite dangerous. You don't notice that you start talking to a new person. And when it comes to analyzing data, that has real repercussions, because you need to be able to comprehend your data to make discoveries. And you need to keep track of what you're doing to avoid mistakes. And you also need to keep an eye on the larger research pictures to make sure you're doing good science. But unfortunately, as data scientists, we're like these people providing directions. We're providing a very distracting set of directions as we do data science, and those directions go to our computer. So it's hard for us to do meaningful data science without using a computer. But if we want to do something on a computer, we need to deliver to the computer a set of directions that it can understand in machine language. And machine language is nothing like human language, and at some point it just dissolves into zeros and ones and bits. And we could spend a long time learning how to write assembly languages and getting good at it, but it would take your entire college career, and at the end of the process you wouldn't be a data scientist, you'd be a computer scientist. In practice, we don't do that. We use programming languages. And they sort of meet us halfway. Like, for example, we can use C++. And as long as we can translate our thoughts to C++, it'll take care of the rest, and it'll get the computer to do what we want to do. Unfortunately, most programming languages are written to work very efficiently with a computer, with not much thought given to how they work with a human. For example, if you want to write C++ code, you need to do things like declare variables, increment over for loops, and whatnot. And these aren't things you do on a daily basis. They're a challenge. They're hard to do. And if we make glaring lacks of observation when we're telling someone how to cross the street and go around the corner, imagine what we're missing as we're trying to figure out how to translate our thoughts to C++, make sure that code works, and so on and so forth. It seems really trivial, but I contend that actually makes a fairly large difference. And this is, how preoccupied we are with our code is going to determine whether we see the world like this, whether we see our data like this, or whether we see our data like that. And as a data scientist, you really want to make sure you're seeing the whole picture and making the discovery you're setting out to make. Right. So this is where R comes into play. One reason I like R is that at its best, it's very, very human-friendly. It's very readable. This is some R code. As long as you know the vocabulary of the functions and you know how to read the pipe operator, you could almost read this like prose. What this is saying is load the dplyr library, but then take the diamonds data set. You can read the pipe operator as and then. If you've never seen the pipe operator, it just takes what's on the left and passes it as first argument of what's on the right. So here we go. Take the diamonds data set and then filter it to just the rows where caret is greater than 1. And then take that and select from it the x, y, and z columns. And then take that and transmute it to create a new column called volume, which is equal to the product of x times y times z. And then take that and summarize it to a single value named average volume, which you calculate by taking the mean of those volume values. If this is your first time seeing the pipe, you're going to say, well, that's not human-friendly at all. But actually it is. I just read it to you. And I'm here teaching a course, and this morning at lunchtime, I taught some people how to use the pipe for the first time. And by 5 o'clock when we stopped, they were already using it to do very sophisticated things. As a teacher, I can guarantee you, it's really easy to learn this, as computer languages go. So if I were to put R on this diagram, I'd put it right here. I think R is unique among computer languages in that it's designed to be human-friendly, or at least the best parts of R are designed to be human-friendly. As a data scientist, that makes a difference. And there's a reason for this. Let's talk about why R is human-friendly. R code has not always looked like this. In fact, if you study the history of R, you'll notice it started with a for function that was very similar to the for function in C++. Not completely intuitive, but it does its job. It does it fairly well. A little later, our developers developed the apply family of functions that do the same exact thing, but arguably in a more intuitive manner. And then more recently, Hadley Wickham and Lionel Henry developed the map family of functions that do the same task again, but in a much more human-friendly manner yet. And this idea of evolving towards a better and better expression is very common in R. And it's not by chance. This happens because of a design decision that was made when R was first created, or when S was first created, I should say. And this is what I mean by that design decision. Some languages like Go and Python adopt a very conformist philosophy towards their developers. We could sum this up by the Python maxim. There should be one, and preferably only one correct way to do something. And the idea is, as long as you can write your code in that correct way, then you can feel fairly confident that it's going to work and be maintainable in the future and so on. I don't feel qualified to talk about how these languages maintain that sort of conformity, but I want to talk about how R avoids it. R adopts a more permissive philosophy. It's a language like Lisp and some others that are designed to purposefully be flexible. And those of you who use R may have noticed this. You could do lots of things in R that you wouldn't be able to do in other languages. Some people say that's a downside of R, but I think that's what allows us to evolve better ways of doing things and make R eventually become a very human-friendly language. And if we compare two snippets of code, one written in R and one written in a more conformist approach, you can see what developers are up against. I have a piece of code from the dplyr package written in R right here, and one from the dpython package written in Python. Now I like Python, and I like the dpython package. I should say I haven't checked in on dpython in over a year, so things might be a little different now. But I think comparing these two does give us a sense of what developers have to do when they work in a permissive language versus a conformist language. Both pieces of code do the same thing. They take this data set named diamonds, and they focus on this caret column of diamonds, and they filter the data set to just the rows where the caret value equals the mean caret value for the entire data set. Let's look at how they do that. dplyr takes advantage of two of R's more flexible features to make this an easy thing to do for a data scientist. First of all, it uses non-standard evaluation. Caret is not an object that exists in the scope of filter, which it's a column in the diamonds data set. But R allows you, as a developer, to do things that makes it easy for the author of filter to arrange for anything past the filter to be run in the context of diamonds where caret will be found. Next, dplyr is taking advantage of lazy evaluation. R doesn't aggressively evaluate everything you put into here. It will eventually evaluate this context, but not immediately. So it's easy for the author of dplyr to arrange for this not to be run until we can safely find caret in the context of diamonds. As a result, the user can write code like this that just says, well, I'm working with diamonds, I want to filter it to the rows where caret equals this. and it's actually very human readable. And deep Python's a little different. If you only use R, you might think that non-standard evaluation, lazy evaluation, anonymous function, flexible scoping, the flexible things in R exist in every language, and they don't. And deep Python has come up with another way to do these things. First of all, deep Python has a problem that in Python, this is run immediately. Garett is still not in the scope of CIF. So the way they solved it in deep Python is they invented this X object. If you want to use deep Python, you have to import the X object. But once you do that, you can call the variables of diamonds as methods of X. X was written very ingeniously, but with a lot of hard work to sort of recreate the non-standard evaluation that you find in R. If you want to run a function on that Garett variable, you could call that function as a method of X as well. But you're limited to the functions that are already implemented as methods of X. So whereas in dplyr, you could make a function up off the top of your head and pass it to dplyr, and it's going to work. Here in deep Python, you have to stick with what already exists, which is actually a real limitation. I think that there's two effects of this difference. The first one is felt by the user, the data scientist. When they write this code down here, they have to work with X in their thoughts. X has nothing to do with their data, has nothing to do with the problem that they're solving. It's a purely computational concern. But they have to manage that concern, and it consumes mental bandwidth, which I think is undesirable. The second effect has to do with the developers. Let's go back here. It's harder to make a better way of doing things in a language that assumes there's only one right way to do it, and we've already figured out what it was. It's harder for conformist languages to evolve. And that's fine, they're not there to evolve, they're there to do something else. But if you look at the names deep Python and dplyr, you see that it has a real world effect. Deep Python is named deep Python because dplyr came first. And dplyr struck the author of deep Python as being a good idea, so they're trying to re-implement it. The fact that dplyr came first, I think, hints at this idea that creating a natural language of solving a particular task is a better fit with R than with other languages. And what dplyr actually is a small, little language that you can use to manipulate tabular data. It's a domain-specific language for manipulating tabular data. And this flexibility that you see in R makes R a very good language for creating domain-specific languages. These are little human-friendly collections of vocabulary that solve a particular task. And if you look at R, you'll see it's filled with domain-specific languages. There's a domain-specific language for making graphs in R. That's what ggplot2 is. It's just some vocabulary and grammar you put there to make graphs. There's one for manipulating data. That's what the tidyverse is. There's one for creating reactive web apps. That's what Shiny is. There's HTML widgets for making interactive graphics, and so on and so on. R is a language for making domain-specific languages. You may have heard the words R and domain-specific language together before, because a lot of people say R is a domain-specific language for doing statistics. Well, the first domain-specific language made with R was to do statistics. And that language is still baked into R. But don't be distracted. R is not a language for doing statistics. It's a language for making very human-friendly interfaces for solving particular tasks. An important question to ask at this point is, what do we lose on the back end for this human friendliness on the front end? And the answer is not much, but my diagram kind of obscures why that is. As a general rule, R functions call another language on the back end. It could be C++, or it could be Fortran, or it could be JavaScript, or anything else. This is a design feature of R that goes back to the very beginnings of R. R began as a language named S at Bell Laboratories a long time ago. At the same time, they're creating C and other things. And the authors of S, Richard Becker and John Chambers, faced this problem. They had a lot of excellent Fortran algorithms to analyze data with, but they're all written by different people. They sort of expected the data to come in different ways, and they had different interfaces. And as data scientists wanted to rapidly cover a lot of ground and iterate, it was just kind of a pain to move from one algorithm to the next. So they wrote S to be a uniform interface to all these different algorithms. You can use the same syntax on the front end, and S would take care of the details on the back end. This design principle still exists in R today, and you can seamlessly integrate R with every programming language that I know of, as well as lots of software for databases and distributed computing systems. And I think altogether, this suggests a great way to make data science tools. You use R to create a human-friendly front end that allows data scientists to do what they do best, which is to notice things, make judgments, and avoid mistakes. And then a machine-optimized backend that can use whatever technology is best for solving that particular task. And it'll just work with the computer and the user doesn't have to think too much about that. Right? So that's why I like R. That's why I think it's really good for data science. It's not necessarily RStudio's view, I don't know if it is, but it's my personal view, and it's unlocked a lot of things for me. What I'd like to do now is invite my colleague, Nathan Stevens, to come up to talk about how we at RStudio see data science and some of the tools that you might not know are out there to help you do data science with R.
Give me a sec to set up.
In the meantime, I'm gonna, so they actually brought some swag, and one of the things I did, can I?
Yeah, go ahead.
So there is an R for data science book, which is written by both Garett and Hadley, and it's actually autographed. So, yeah. And it's actually autographed in with the pipe, the deep plier line. So Hadley autographed the advanced R book for me years ago using when this first thing came out. I still have it. So I'm going to use. So we're going to use. Okay, so we're going to use a little random generator that Harlan built years ago, and we're just going to, these are all the RCPs. Now we had 236 RCPs. There are not 236 people here. There is, I don't know, 90? Okay, 90. So less than 50%, which is lower than our usual trend. But anyway, so if you're here, you get the book. If you're not, I'm sorry. Ah, there you go. And you guys have some stuff to give out, right?
We have cheat sheets, and stickers.
I'll learn some. Okay. So for those, the RStudio cheat sheets are amazing. These are nicely printed in glossy paper. So, and then a bunch of stickers. All of the different Tidyverse hexagonal stickers. So I'm gonna try to arrange them while we talk, and I'm gonna grab some.
Okay, that's loud. I like questions along the way. I go fast. I like a ton of material, so I usually skip through really fast. But if you have questions, let's pause for questions and take those along the way. I'm Nathan Stevens. I'm local. I live in the Columbia, Maryland area, generally speaking. I used to live down here. Years ago, I lived in Alexandria, an old town. I worked just over by Lafayette, in the Foggy Bottom metro stop, I think is what I took. And I love coming back to Washington. I'll be here this weekend with some friends doing the tours. And anyway, it's great to be here and go through some of this content. My job at RStudio is to do solutions engineering. So we do a lot of pipelines, right? We do a lot of enterprise support. We talk about how to use the tools and how to scale those tools out, how to manage them, how to install them, do a lot of that infrastructure type of work. Part of what we've worked on lately has been, well, let me just jump into the presentation, and I think it'll be really clear like what we're talking about here. And like I said, I'm gonna skip through this pretty fast. we're going to talk about the tidyverse and RStudio Connect. Just going to skip that and that. Who here has heard about notebooks? Who uses notebooks? Great, great. Okay, that's great. For those of you that haven't used notebooks, it's a way of organizing your code into code chunks, and you put narrative and output around those code chunks, and when you're done with all of your code chunks, you can render those into a really nice document that you can share with other people or share with yourself in 6 months. I'm going to use notebooks in the presentation. Shiny, let me see, raise your hands for people who use Shiny. Okay, that's what I would think. Okay, so Shiny is a framework for building web applications. Markdown, that's the grandfather of yep, using Markdown, right? So Markdown's like a notebook, except it runs in batch mode instead of interactive mode. And you can render these things out to HTML, PDF, Word, and even slide formats. We're actually working on PowerPoint, so look for that in the future. Dashboards. You can build dashboards with Flex Dashboard, Shiny Dashboard. Anybody use Flex Dashboards? It's an R Markdown format. Okay, fewer. We're going to use that tonight too. APIs. This is fun. We started using supporting APIs. So, like a Shiny application is about a human interacting with a process, an R process, with a nice GUI and everything in front of it. An API allows two machines to talk to each other. So that becomes useful when you're like building pipelines, or you're scoring a lot of code, or you're submitting a request by the web. And these are now supported inside of RStudio Connect. I don't know if anyone's using Plumber APIs brand new, right? Okay. Awesome. I think we might have a Plumber API sticker for you. If you want him. I don't know if you want that guy or not. I can't decide. So I asked Hadley, what does it take to get a hex sticker? Hadley, he goes, just give me your picture and I'll put on a hex. So real low bar there for the hexes. Okay, so you teed this up nicely for me, Garett, about how we think about data science, and this is kind of the process. You got the book? So this is in the book, right? This is right there in the intro section of the book, and you can get this book online for free, right? But basically, we're talking about bringing data in, cleaning it up, understanding that data, and then communicating it out. And this is a discovery process, right? This is not about building production, code and hosting that and scaling out to millions of people. This is a very data science-driven discovery process. And there's a lot of talk about how to import and tidy and understand data, but tonight I'm talking about communicating data. So what do we mean by communicating insights? Well, we're talking about people who have something to learn, right? So our process, so let me back up for a second. My background is in statistics, and I'm an analyst. I've been working for a long time as mostly in marketing applications. And my observation is that most data scientists are there to learn things about their data and influence decisions. And so you're trying to make change or get people to take action on the things that you learn. So that's what that's what data scientists do. And the people that are consuming our content as data scientists are trying to understand what those things are so they can achieve results. Right? So those are your managers, your peers, and your students if you're in school. Okay, so this is how this process usually works. You build a bunch of artifacts like a plot or a markdown document, and then you send it out to these people, or your students, or your boss, or your clients, and they ask a question. And they say, well, what would happen if you did this with over a different time frame, or if you did this over a different client, or with a different model? And you go back and you update that content, right? So after you update your content, you produce a new artifact, and that artifact goes back to the content consumer, and that person then asks another question, and you rinse and repeat. You go around and around on this. So I don't know if you guys have been through this process before, but I know I have, and there's two things that are really bad about this process. The first is that the data scientist becomes the bottleneck, right? Everything has to go through that person. It slows things down. And the other thing is it becomes this nightmare of a logistic problem, a logistic headache, because You have to like keep track of those emails. You have to figure out like version 1, version 2. You have to reconcile things. You don't have a single source of truth, and it becomes very difficult to keep that process going long term. So I would propose a different solution, and a lot of this would revolve around the people that are asking the questions being able to interact with the artifacts. So you can think of something like Shiny, right, where you're actually interacting with the application. I'd like to be able to, email, distribute, schedule, output to these people on a regular basis, so it doesn't have to go through me every time. And I'd like to do all of this in R because that's the tool I use. So this pushes some of the control from me, the data scientist, over to the content consumers, my boss, if you will, to take care of, to self-serve. So how do you do that? Well, R actually has a lot of ways to do that today. You can do that with open source tools. I've actually done a lot of that in my background, and it's a lot of manual effort. RStudio has a new product called RStudio Connect that does a lot of this automatically. So I'm going to show you RStudio Connect tonight. I'm going to show you how you can publish this work and then self-serve on top of RStudio Connect. And you can also do this through open source means. So we're going to talk about how to do it through open source means in case you don't want to use Connect. Connect is a professional product, so it's not necessarily for everyone. But I think the concepts here that we're talking about are very important for everyone to hear. So let me toggle over and do some demos. All right. The first thing I'm going to do here is I'm just going to run some of this code. This is a plot. Let me go through and run that. Run the ggplot. And we get the rise of the hyperdrive, right? So this is Star Wars data, so I pulled in some Star Wars data. And just to familiarize ourselves with the data, we have, 7 movies, seven episodes. And you can see that the hyperdrive actually goes up over time, and there's this kind of interesting pattern with the different series. That the first series has fewer hyperdrives than the second, and then of course we get full throttle with J.J. Abrams there in the last one. So what with this thing, what I can do is I can email this out. I can put it on a file share. What's really nice, what would be really nice is just be able to publish this somewhere. Like if I hit RStudio Connect and I just give this a name, and I give it IPlot 1. And this thing will actually go ahead and push that plot out, and now I've got a hosted solution, right? So I've got a hosted version of my plot. It's a single source of truth. I can decide who I want to share it with. I can share it with just me, or I can share it with everybody. I can add collaborators, right? It's all good. I've got a place to put all my content. But just storing content's a really boring thing. We can do a lot more than just host content. So let's go through a notebook, and I'll show you what I mean. For those of you that haven't seen notebooks, this is basically it. You have got some narrative at the top there, and then a code chunk, and then the notebook will actually produce the output. So let me go ahead and read in some of these data here. I'll show you the tidyverse in action. I'm gonna filter some data. I'm gonna select the data. I'm gonna mutate it. I'm gonna sort it, and then I'm gonna run another query that does all of those, that does a summarization of the data. Run it here. The notebook gives me this nice output. I can see each one of these. This is the first one was a filter, right? And then this one's a select. You can see that I selected just the columns I want. This one was a mutate. I created a new variable called BMI. And this is an arrange. I've sorted the data. And this is a summarization of the data where I've counted the number of variables in N. So those are the basic verbs of dplyr, if you haven't seen dplyr. This package in the tidyverse is called Tibble. Tibbles are, as a way to reimagine the data frame. It fixes a lot of things in the data frame. One of the things I hate about the data frame is that it creates strings as factors. So I typically work with large data. That's been my history. If you ever try to like pull in a lot of data where it creates a string as factor, it's a total nightmare. So fixing little things like that's really nice. If I run this code chunk, you can see that here on the data frame, I have a factor for these movies, and here on the tibble, I have a character. So if you're not using tibbles, they're pretty timid actually. They're pretty easy to use. So per. So let's talk about the per package. Per is a way to kind of fix the lapply function. So I used to use lapplies, nested in lapplies, and then the occasional sapplies, right? And then mapplies if you get really out there. Per. So I used to work really hard. I would work really hard to make my data manipulation look good, and I would work really, really hard in R to do that in the base packages. And then I would look back at my work, and it just looked terrible, like every time. And I think part of that reason why is because I always had to figure out like which way should I do data manipulation in R, and I thought that was a terrible question. This might go against a little bit with what you're saying, because I always felt like there was like 5 ways of doing anything in R, and they were all like not give me what I wanted. So dplyr has this nice clean syntax that's very consistent, and you can actually read that code when you're done, and that's what kind of brought me over to dplyr. My code, specifically, like when I wrote my dplyr code, I finally had R code that looked presentable. All right, so per. If you haven't seen per, basically use the map function instead of the lapply function. So this lapply is going to take films and apply a function across them. This map function is going to do the exact same thing, except it's going to just pull off title. And this character function is going to organize the data in a nice character string. So this last function is the one that you want. Let me show you why that is. So this is the lapply. I'm just trying to pull off the titles from that list. Here's the map. Looks like the same, exactly the same. And this last one, map character. Oh, finally I get exactly what I want, right? All right, so I'm going to show you what this all looks like together. I'm going to run a tibble. I'm going to run some per commands, I'm going to run some dplyr commands, and I'm going to show you the output. And this is nice, right? This is what we call tidy data. You've got one row for every record, one column for every variable. It's very easy to understand. And I didn't show you what this looked like before, but before this was just a list of lists of lists. So it's really cool that dplyr can actually translate your code that easily and give you what you want. All right, so here's the plot again. I'm going to do another plot here, just to familiarize ourselves with this plot. Here we've got number of ships total on the horizontal, and we've got number of ships with hyperdrive on the vertical, and you can see this pattern here of the number of hyperdrive ships actually increasing within the series. So you have New Hope, Empire Strikes Back has more, Return of the Jedi has more, Phantom Menace. So what does that mean for the next movie? Well, Force Awakens over here, we're going to have more hyperdrive ships, right? With at least, a similar percentage that are hyperdrive. I don't know. I'm not even watching the previews, so I don't even know what I'm talking about. All right. Okay, so now what I said before is you can render these notebooks. So I just previewed the notebook. It's too small to see here, so I'm going to pop it out. And this is a nice notebook, right? I can read this notebook because it has narrative in it, and it's got the output in it. I can go back to this notebook in 6 months and say, I know what I did. And I can literally say that because I wrote this notebook about 6 months ago, and I can still go back and say, I know what I did. I think the term, when you talk about reproducible research, I would love to think that everything I did was being picked up by the community and being reproduced all day long. The truth of it for me personally is that I just want to be able to read my code in 6 months from now. Thank you. All right. So what do we want to do here? Well, we could publish this thing too. We can publish this to RStudio Connect. We can publish just this document. We have this choice here to publish the document with source code or without. I'm going to choose without, and I'm going to give it a name, and I'm going to publish. And you're going to see that this thing is going to like launch a new tab. And I can open this up, solo, and now I have a place where I have a place to store all of my research in one place, and that's great. So I can actually share that URL with anybody in the world. They can see that stuff. Now, if you don't want to use RStudio Connect, that's fine. You can just take this and put this document onto a web server, and that's fine too. That put on SharePoint or something, that will work. But there's much cooler things you can do here than just do a static notebook. You can actually make this live. So let me show you what happens next. I'm going to knit this, show you a different R Markdown document. Okay, so this is Luke Skywalker Quick Facts, and what this document does is this takes queries in the API, the Star Wars API, for data about Luke Skywalker, and it then queries Flickr for information around, or for images of Luke Skywalker. So you see it did pull one up here, and it pulled in some data about Luke Skywalker, right? He's got blonde and blue hair, right? Blonde and blue eyes, and he's this one they got wrong. This is Tatooine. I don't know, maybe that's right. Maybe that's the sand from Tatooine. And then it tells you what the films are. Okay, this is what the document looks like. And here, if I come down here, I can see Luke Skywalker, right? But I don't want Luke Skywalker every time. I want to like query this exact same document with other characters, like Yoda. So one thing I can do here is I can type in Luke Skywalker, right? And I can type in Yoda, and that's going to replace every instance of Luke Skywalker with Yoda. And I have to go through the code to make sure that it's correct, and then I have to test it out to make sure I didn't make any mistakes. That's like a lot of guessing and checking and double checking. The best of us make mistakes when we do that. So there is a better way of doing that. You can actually parameterize this document. And the parameterized R Markdown documents have been around for a while. I'm wondering if anybody's actually used parameterized R Markdown. This group rocks. Okay, that's awesome. I like visit a lot of places, and I don't see that many hands. So I'm glad to hear that. I would love to hear some of your stories about like how you're using parameterized R Markdown documents. Let me show you how that would look, because I think they're great, right? So in my marketing background, I had to generate a lot of reports, a lot of insights, and there wasn't a great way of doing that. So I ended up making a lot of PowerPoints and making a lot of that, doing that cycle, making a lot of mistakes. So let's do params, character, and let's do Yoda, okay? And then here I'm going to take this, and this, params, character. I'll just replace all of those. Okay, so what we've done here is we've changed the comments here, the inline comments to be param string character. We changed the R code to also be param string character. And those are going to refer to this YAML header. So let's give this another shot and see if we can get Yoda. Okay, great. So it worked. It picked up Yoda. Okay. Now let's see what this looks like inside of RStudio Connect. I'm going to click on. Close that down. Okay, so here I've got the document with Luke Skywalker, and if I want to get back to Yoda, I can just click here, and I can scroll down to Yoda, and I can run the report, and this report is going to go ahead and run the report with that parameter. So what's going on here? Well, at the heart of RStudio Connect is R, right? So that's the nice thing about R. It's kind of like the evolution here that we've gone from is from like Shiny Server to Shiny Apps IO, and then to RStudio Connect. They're all going to be R-centric, right? Running R at its core, and that lets us do things like this. It also lets me store, my pages up here, right? So if I want to see BB8, I can click that and take a look at BB8. I can go ahead and refresh this report if I want to. I can there's BB8. I can email this report out to people, to just me or to collaborators, and I can open up in that solo mode. I can see past versions of this if I want. I can download that bundle. So it becomes it becomes a repository for all the content that you produce in R. All right, so this is starting to look a lot like you would see in maybe a Shiny app. So let me toggle over and talk about what Shiny looks like in this situation. I've got a Shiny Flex dashboard here. It's also based on the Star Wars data, and I can see that back here. So I'm going to hide this for a moment. What this does is this gives me some plots of the speed versus cost. I don't know who these people are that create Star Wars data. Do we have anybody here that creates Star Wars data on their own time? I don't know, maybe. I'm not judging. We can all let our dork flags fly. Okay. So this is basically building a model, because look, we built models on top of fake data, so that's pretty bad. This model says cost, passenger, and cargoes are significant predictors of speed. Well, if you go to the model residual plot, you can see that, yeah, it's not a very good model. Leverage plot, it's even worse. We didn't spend a lot of time on this model, but maybe I'm going to go ahead and remove like the Genosian Starfighter. Okay, that point's gone. I'm going to get rid of this point as well, the C997. Okay, now does anybody in this audience know what a C997 is? Okay. Now I'm judging. Okay. All right, so our model is pretty bad. It looks like a ski jump, but at least it's tolerable. You can come back here and see that nothing is significant any longer. So the data, we've confirmed that the data are totally bogus, right? Which is good. That's a good thing. That, yeah, people didn't spend that much time trying to actually make sense out of this. All right, so what's going on here? Well, Shiny is running behind. This is the Flex dashboard, and it has Shiny at its core, and that's why I can interact with it, interactively, interact with it, and I can, eliminate those objects. I can change the transformation, and I can see all the updates. And the nice thing about that is that you can actually have a lot of people, interact with these Shiny apps. So over here, if you've got click on runtime, you can see that I've allocated 10 processes to this application. But if I want to, I can allocate 100 or more. And I can set them in processes and the number of connections per process as well. So that allows me to scale this out to as big of an audience as I'd like. I can also see the logs of this application. So I think when you're a data scientist and you find out that you can actually build web applications, a number of really funny things happen to you. First of all, you get really excited, like, wow, I actually built a Shiny app. That's really cool. I can't believe I did that. Then the second one is kind of like, what have I done here, right? Because you've suddenly stepped into this world of application development, which isn't something that most data scientists get. Well, I shouldn't say statisticians like myself don't get trained in application development. So then you start seeing weird things like I'm going to host my Shiny apps on my laptop, and you have to come to my laptop and look at it. And then you get this world of deployment, and it starts to get pretty scary. What we've tried to do here is make that world extremely easy. So I don't know if you guys have heard like the pit of success that Joe Chang talks about, right? And Hadley too. We've tried to make this like really easy for somebody that's never done application development to build a Shiny app, deploy the Shiny app, scale that out, and manage that Shiny app. I think that's amazing. Okay, but that's not the only thing that we've done, right? So we've also done APIs. So let me show you a Plumber API. You can ignore this code, this stuff at the top. What I've written in some regular functions. These are all helper functions. So this is just regular R code. And then the Plumber API is right here. If you used Roxygen, ROxygen, you're probably familiar with like the hashtag star notation. That's going to be used here in Plumber as well to define your inputs. So I'm defining my API inputs here. My crew, cost, passenger, cargo, length, and then this is the endpoint, the score ship named under get. So that's the input. Okay, and then what I do here is I go ahead and I just write a function, an R function, that is associated with that API. And I can publish that to RStudio Connect. You can also publish this to other places as well. So let me show you what that looks like. All right, so this is a Swagger page. Swagger isn't ours, right? Swagger is just a wrapper on top of this API that we can use to, that we humans can use to see the API. So if I hit the get endpoint here, here's the score ship named endpoint. I can see the parameters that I defined. I'm going to try it out. I'm going to do length of 12, cargo is like 10,000, passengers 2, cost is 10,000, and crews 2. Okay. And then I can execute this endpoint. It's going to load, and I get some output. This is the important part here. This is the output of the prediction API, 223. That's the speed. And then this is how you get that output programmatically. I'm going to go ahead and grab this piece and open up another tab and put it into the browser. And you can see there's the 223 again. If I decrease the crew to 1, you can see the speed actually speeds up. It's like getting rid of Chewbacca, made the ship go faster. So you can see this is a REST-based call, right? So this is really great that you can query R. I'm querying R, running a job. Let me go back here and show you what it is we're doing here. So when I query that, it's passing into this function. It's grabbing the inputs. It's just doing a check here, and it's doing get scores. Well, what's get scores? Get scores is a function here based on the coefficients of my model. This is scoring, right? Based on the model. Where'd the model come from? Well, I read some of this stuff in from file. So I'm actually able to score a lot of data here that's being passed through Plumber by other applications. I can write any arbitrary R code to support that API. And if you don't have to host APIs in Connect, but if you do, you can very easily scale like the number of R processes associated with that API. All right, so that was pretty fast. Let me, I'm going to wrap up here, but I wanted to go back and I forgot to mention one thing that was important about the parameterized R markdown documents. So what you can do here is you can go through like this one. This is a stock market report. It's got really interesting parameters. You can knit this with the parameters. And I neglected to show that to you. If I pull that up, I can choose all the parameters here and do, choose a stock ticker and a modeling and a forecast, and that will run the document. So let's get a stock ticker here. Who wants to give me a stock? What do you guys invested in today? Wait, so I know Apple. Apple's AAPL. What's Chipotle? Do you know Chipotle code? CMG. Good. CMG. How is it like 12 people know this document? Okay, CMG. We can do Apple also. This one could take a little while. All right, so I'll pull this out so we can see it. All right, so this is Chipotle. This must be the whole salmonella outbreak. And they had something else. I can't remember what happened else recently, but there was something that went on. So yeah, I don't. This doesn't bear out. The Chipotles I know still have really long lines. So okay. Let's go back here and we'll run the, let's run the report this way this time. If I do a render, and I do a Control R, Parameterize stop report. So you can see this time I'm gonna say ask what the parameters are. Okay, so ask. This is all open source RStudio stuff, right? So we'll do Apple this time. Save it, comes back here, and it's it. Now you can imagine if you don't like, excuse me, if you don't like, did that not work? Here it is, okay. So Apple is just up and up and up, man. Doesn't matter, you just take off as many ports as you want, that stock price just keeps going. Okay, so you can do this programmatically too. If you come in here and do params and you do a list and you do like stock, if you do ticker equals, APL, something like that, that will also render as well. So you can take that code and you could put that into a cron job. You could render the documents, right? And it would like spit that out. And then you could write another little script to post that to a web server. And you would have basically what you need to do to send those reports out. So there are very simple ways, frankly, of doing it programmatically. All right, just coming back to summary here. I appreciate you guys having me and Garett down here. I've been looking forward to this for a long time. RStudio Connect allows you to publish and self-serve. I think we covered that. And then with the data science piece, we've been building packages here for all these different things. In fact, we've got APIs to add in there too, right? Our Markdown Shiny APIs. So we're trying to, connect up this whole workflow. I will mention that, we've done a lot of work here on this back end here on the data sources. So has anybody been checking out our RStudio version 1.1? Yeah, a little bit? Yeah, okay. So the new version of the RStudio IDE is coming out very, very soon. We have a preview version. We've been blogging about it. There's one of the major features of that is the data sources connections pane. It's actually in this version I've been using. I'm showing this because it has nothing to do with my presentation, but I really like it. You go here now, you have a connections pane. You can establish a new connection, right? So here I can choose like SQL Server. I can test the connections to SQL Server. I can put in my password. Anybody work with databases here? You don't have to raise your hands. I'm pretty sure everybody works with data of some sort. Okay, and so I can hit OK. I'm going to connect to that. I have to put in my password again. And I come in here, and I can browse my catalog, my schema, my tables. This is the bank data. I can see all the columns in here, and I can preview the table. Okay. So we know that it's been a little tricky to analyze data, and then you can use dplyr on top of this too. The other thing that we did is we've got dplyr, a generalized SQL engine for dplyr. I'm not going to go into that right now, but you can see that on our blog. We've tried to make the ability to analyze enterprise data warehouses with your RStudio IDE a lot simpler, and we're really excited about that. So that's it. Nobody asked any questions along the way, but why don't we take questions now? And Garett, you should probably come up. in case any are for you. Any questions? Yeah.
In the code to the ship speed API,
Speak up a little bit.
in the code for the ship speed API, I saw in the line that was like the response, it said response 200. Like, is there some meaning to the 200 in that syntax?
Which file was that? Was that the our Markdown document? Oh, the Plumber API. Oh, that one. Yeah. Let me come back to that. Are you talking about
Add response.
this one? Response 200. I don't think response 200. Yeah, code 200. Yeah. You can always get more information about Plumber at our Plumber.io too. This was written by Jeff Allen, and Jeff Allen also helped write Shiny Server Pro, RStudio Connect. He runs a fairly large team now at RStudio building products. Was there another question?
Yeah, so I noticed in the initial GW that you created, there was a style from 538. So I've used typically color river, which is implicitly open source, but it is, so does 538 put stuff up on like styles or etc. model stuff up on
Do you know where 538 style came from in IPlot? I'm assuming they contributed it.
Theme, 538 contributes a lot of data, but I'm not sure if they contribute their theme or someone just made it up to look like theirs.
Oh.
Yeah, I don't know the source on it.
Okay,
The
good.
GW Themes package contains things that emulate all sorts of documents.
Okay. Wasn't sure if there was like an actual collaboration there. That's
It very
I
well
don't.
could be, we just don't.
yeah. Got it.
Anybody working with Nate Silver? I got the sense it was a collaborative. I can only guess. We're just guessing now.
Don't tell me.
Yeah. Good point. Yes. Yeah, we need to do that. Yeah. So when we when we built those slides, these slides are a few months old, and Plumber's brand new. Yeah. So, but in my I attempted to show you my Slack thread, but I actually have the Plumber API sticker in my Slack thread for that specific period. Point. Yeah.
You can also show the new version. I don't know if this is inserted, but the theme,
Yeah, let me show you the dark theme. So what I've been doing here is, this is RStudio Server Pro, because most of my work is with the enterprise crew, and it runs in a browser, right? So I didn't point that out. If you've never used RStudio Server, it runs in a browser. This is the Chrome browser. It behaves just like the IDE on the desktop. And one of the cool new features in 1.1 is the ability to change the appearance of the IDE. If you go to Global Options, click on Appearance, you have to do Modern, and then choose a dark one. I don't know what we have, Dracula? Let's do that. I've never done Dracula, okay? And it turns dark, right? I did this, I tried this for a couple of days, it just wigged me out. And that's kind of funny too, because I'm kind of a Linux guy, so I like dark, terminals and stuff. Oh, that's another thing. I don't know if you guys saw the terminals. This is really cool, actually. If you guys have needed to interface with a terminal in the past, like PuTTY or the little shell script, we have a full-fledged terminal in here now. So this is the whole thing. I can see, everything, right? AL, it's got tab complete, right? If I do a cat, what is it, demos, right? That doesn't work, of course, because it's the wrong command. I can do a vim on,
Between this and the dark theme, you can be a full-fledged hacker.
Yeah, you really can. You can update. You can do a wget, RStudio Server Pro, and then you can do a apt-get install right here and upgrade the RStudio server inside of RStudio server. It works fine. It gives you a little brief hiccup, and then you have to refresh it, and it comes back just fine. So this is super cool, especially for like Git commands. Like we've upgraded Git as well. We've put in the ability to use branches, which is really cool. But if you've used Git a lot, you'll know that sometimes you have to get into Git and do specific commands. You can do that now pretty easily.
Yeah. First, I would like to thank both of you, because basically you got me a job. I was a pure scientist, and I got very interested in art. Learned a lot basically through people like you, by watching all the webinars and reading books. Did not go to uni, but got a planted a job in data science that I love. But now it is a problem that hopefully you will help me solve. And it comes, probably you can answer this question from the educator point of view. So now I work developing software for a community of researchers, right? So that they can analyze their specific data sets in a consistent and fast way. But the barrier that I'm facing in developing the products that I know work best for people that want to get things done but are not so interested in the mechanics. The barrier that I'm facing is that the people that are more data savvy are people that grew in the old days of R, and when they kind of see me developing the tools that I build with, say, tidy evaluation or deployer inside functions, they don't know what it is, and they just say, no, let's just stick with base. So, do you have any advice in how to influence these people from an educator point of view, how to educate them without losing my job?
There's a high stakes piece of advice. I don't want to get you fired. Do you know people who are curmudgeons in the R space?
Often academics, I find that if people learn something that works for them, it's hard to learn something new, so they're very resistant. But if you get them interested in Shiny or R Markdown, these are things where really if the product itself and the value that delivers doesn't convince them, you're going to have a hard case convincing them. But they're not going to use base R to make an interactive web app, but they're not going to use base R to export a PDF or a slideshow that they're doing. And it doesn't take much to learn R Markdown. But I don't know.
Are they telling you that you shouldn't use that stuff? Is that what they're doing?
Because I'm building packages for them, and the only people that can actually review my code are the ones that know more. But when I try teaching the tinyverse to newcomers, they just go, "Wow, that's so easy." But then when I kind of go back halfway and they review my code, they go like, "Well, what's this?" Right? It's totally new for them. Am I the only one with this kind of problem? Or perhaps we can drink a beer and kind of cry together.
That might be good to get some advice.
We'll try to make it easy for you to educate them with examples of websites and tutorials. But beyond that, they're going to have to learn it if they review your code. Or hire someone else like you. It is new, which means there's not many resources to make.
Other questions?
I just want to quickly add to that. I have a similar problem. Trying to develop a package and develop a team leader. I think that it does not encourage us to use that is an implementer because it says so it encourages us to use base R because as Gary just mentioned that IPlot is more designed to be more human friendly. So
beneath the dplyr interface, everything's implemented in C++. So I think they have a misperception of what's going on there with dplyr. And I don't want to offend anybody, but I think large portions of the tidyverse are developed by people with more skill and more thoroughness than parts of base hardware. Like, it's new, and that makes people feel good.
Put that on the article.
So just to finish that with a success story, just by being patient and persistent, eventually, we built a function. We built 3 versions of a function with 3 different approaches, and the ones that were more resistant, the dplyr eventually chose that one because it was so much faster than the others. So sometimes, that just
dplyr is more efficient for a lot of code. Yeah. Okay. Much better.
Sorry.
There's a question over here. Yeah.
So I use R Markdown a lot, and notebooks came out, and I started experimenting with it, but couldn't really do everything so far. So maybe you talk about like what the vision for those sort of different technologies.
What's the difference between R Markdown and a notebook?
And notebook,
Yeah. So there's some subtleties here. I don't have the slide handy to show you, but when you run an R Markdown document, you're going to knit that document when you're done with it. And when you knit that document, it actually spawns up an R process that's outside of the console and batches all of that entire script through that R process. That's a very painful experience if you're dealing with like a lot of data, right? It's just like knit one time, just one time and go get a coffee. Notebooks are meant to be interactive, so what they do is they look the same, they have all the code chunks, but they actually cache all of those code chunks along the way. So that when you're done with all of your work, all you have to do is hit preview, and it just renders the HTML elements of that script and inserts all of the cached output into that HTML document. So I like to say that HTML is, or our notebooks are really for doing data science. I mean, in data science, you're thinking about things, right? You're commenting, you're working things out. You want to see that workflow, and you want to talk about that workflow and how those pieces relate to each other. You want to do that interactively. That's a notebook experience. And so that's why those elements are cached.
So going forward, is the objective to have the same output options?
They do have the same output options. You can still output the notebooks to Word and PDF and HTML. Like those are all the same. When you when you hit preview, it inserts all those chunks into that. Yeah.
I was really resistant to our notebooks since I had a conversation with Nathan. I haven't got back since I tried.
Our notebooks will give you better, will make you be a better data scientist. It'll definitely do that. No, it really will. Because you have to write out what you're thinking about. It's like here, look, I'll do this. I'll show you data science pre and post, right? So I'm going to do this. Let's take a look at MT cars, all right? So we'll do MT cars. So I'm going to do MT cars. All right. Okay. Now I'm going to take a look at. I'm going to plot. I'm going to plot MT cars. Okay. Sorry. And then I'm going to. Okay. So not very good plot, right? So I'm going to go ahead and plot MT cars 1 and 2, right? And then I'm just going to summarize MT cars. Did I do? Oh, summary. Hang with me, guys. Hang with me. Okay. So and there's the summary down here. Okay. So I'm done. Because I learned what was in MT cars, I got a plot of like the variables that were important to me, and I gave a summary. So I'm done, right? Moving on. Well, if I go back 6 months from now and I look at that code, what in the world was I thinking about? I have no clue what I was thinking about. So let's do this again in notebook mode. New file, our notebook. Get rid of all of this stuff. And I'm gonna say, I want to learn about MT cars, and I'm going to insert the code chunk. And I'm going to do the same thing. I'm going to do MT cars. And there's the output. And I'm going to go ahead and insert another R code chunk, and I'm going to say, let's visualize these data. I'm going to do a plot. Right? And I'm going to plot MT cars. And then I'm going to say, that is a bad plot. I just want to see the first 2 columns.
So this is a single R session, right?
Yep, this is one. Everything's going into the R console here. It's all going in here, right? It's not showing up in here actually. Plot MT cars. No, it's not. It's going into an R session though. Let's do this here. And I'm not going to do the last one, but I'll do 1 through 2 here. And then I'm going to go ahead and preview this, give it a name. And there's the doc, there's the notebook, okay? So now I can actually, not only can I see the code, but I can see my output, and I can see these really important columns. Like I'm going to visualize, I just want to see the first 2 columns because there's too many other things. And I can see the output of that too. And then I can put this onto the web server where it can remain until I want to go back to it. And if I want to ever reproduce it, I've got the button right here to download the R code. I can push this up and it will open up the R browser and let me reproduce it right there. So it really does give you a different workflow. I was in Milan, Italy earlier this year when I saw some of the things from Leonardo da Vinci. And one thing that really surprised me was he's got thousands and thousands of pages of notebooks that he did. And the notebooks are really creative. He's got his comments there and his sketches and his ideas and all of his numbers. And I was Leonardo da Vinci was doing notebooks hundreds of years ago. And Leonardo was good enough to do notebooks, then maybe it's good enough for us. Okay. Any other? We'll do one more question. Yeah.
I had a Shiny app that had social inputs, and then I used it to make an R markdown file, and then I went back to it 3 months later, and it was completely broken. It didn't work, and then I had to use all these params things. So how new is that? And is there any way that you could is that really new, or why did it not work? Why did it work and then not work? And then I had to redo the whole thing.
Yeah, one thing so you had a Flex dashboard with Shiny in it, or
no?
Did I get it? Was it R markdown?
It was just a Shiny app.
It was just a Shiny app.
It was download the report, and you downloaded the report, and everything worked fine.
Yep.
And then I went back 3 or 4 months later. And
where did you host that Shiny app?
I don't know. I deployed it someplace, but it was also it worked locally,
So
and then it didn't work locally.
The place, right. So the local thing I might be able to answer. So the Shiny app should go either in Shiny Server, or in Shiny Apps.io, or RStudio Connect. Those are the 3 things that we built specifically to host Shiny apps. If you didn't put them there, they should be stable. If something goes wrong there, you have to talk to your system administrator. If that's you, then you have to talk to yourself.
Well, that doesn't help.
But locally, I can answer. So locally, if you do things that break locally, this isn't just for Shiny apps, but this is for all of our code. You end up upgrading your R versions and upgrading your packages, and that tends to break your stuff over time. And R is on such a fast velocity that things that work today might very well break next month or next week. So that would be my guess as to what happened, is your system did not stay stable. So the solution to that problem is that you do host your applications in a controlled environment like Shiny Server. Yeah. So that's right. So that's the world of application development, right? So that's kind of what I was talking about.
It's just really frustrating, and I wanted to ask what happened. But is this params thing? Is that really new, or?
Well, the params thing is R markdown related, right? So you're not going to do the params in Shiny. The parameterized R markdown have been around for a really long time, maybe 2 years, at least 2 years, at least, probably maybe longer. I think it's probably longer than 2 actually. afterwards. Thanks, everyone.
All right, well, hey, everyone, let's get if you want to go for drinks, hang around here. I've got the little hexagon stickers organized now, so feel free to come up and come next week to Joe's talk, and then see you guys in 2 weeks for Hadley's talk. So thanks a lot.